Today we are going to be continuing with our revision series. Okay, so today we are going to be continuing with our paper June 2024 paper 1. Okay, so we are going to be doing question 3 and question 4. Okay, so the question 3, it consists of number series where we see we have a quadratic series and a arithmetic series. Okay, then we have question 4, which consists of a functions and graph, where we are going to see a hyperbola and you are going to be solving the required answers and you are going to be drawing the graphs. Okay, here we have our question 3. Okay, our question 3 is a quadratic number pattern, which says that consider a quadratic number pattern 3, 7, 12. Okay, show that the general term of this number pattern is given by Tn is equals to half n squared plus 5 over 2 n. Okay, so the first thing we are going to be doing is we are going to be solving to find the quadratic and match it with this one. Okay, so the first thing is we know that the term number 1 is equals to 3 and the term number 2 is equals to 7 and the term number 3 is equals to 12. Okay, so now what are we going to do? We're going to write a quadratic expression for this. Okay, so a quadratic expression is just that for n number, it's just that it has to be a n squared plus b n plus c. Okay, so this is going to be our quadratic. Okay, so we're going to be substituting these values so that we can create our 3 equations. Okay, so let's substitute for 3 first. So it becomes 3 is equals to, so this, since this is 1, we're going to be substituting 1 here. Okay, so it becomes a 1 squared is equals to 1. So a plus then 1 times b plus c. Okay, so this will be our equation 1. Okay, then we go to our equation 2. We're going to be substituting our 7. Okay, so 7 is equals to, then we substitute 2 squared here, which is 4. So it becomes 4a plus, then here it becomes 2b plus c. Okay, so this one becomes our equation 2. Okay, so let's go and substitute 12 again the same way. So it becomes 12 is equals to 9a plus 3b plus c. Okay, this is our equation 3. Okay, so now our duty is to solve these equations. Okay, these are simultaneous equations. Okay, so let's first substitute the term c. Okay, let's make c subject to formula. Okay, so c becomes 3 minus a minus b. Okay, so if you make subject to formula, c becomes 3 minus a minus b. Okay, so we are going to be substituting this in the other terms. Okay, so if you substitute c here, you can see that it becomes, okay, let's put these variables in the left side. Okay, so it becomes 4a plus 2b plus, okay, so instead of c we are putting this, which becomes 3 minus a minus b, okay, which is equals to 7. Okay, so we simplify this, it becomes 4a minus a, it becomes 3a, 2a minus b, it becomes b. Okay, then 3. Okay, so if we put this 3 on the other side, it becomes 4. Okay, so this means that 3a plus b is equals to 4. Okay, then we go on to the next equation and substitute, which is 9a plus 3b plus, instead of c we are putting 3 minus a plus b. Okay, so now it becomes 3 minus a minus b. Okay, which is equals to 12. Okay, so substituting this, simplifying this, we get 8a. Okay, we get 8a here, then 3b minus b becomes a minus, it becomes 2b, then which is equals to, if we say 12 minus 3, it becomes 9. Okay, so this is our equation. So now our duty is to solve this simultaneous equation. So let's write the equation. Okay, the equation, the first one, when we made c so subject to formula, it says that c is equals to 3 minus a minus b. Okay, so when we substituted c in equation 2 and 3, we got that the equation becomes 3a plus b is equals to 4. Okay, this was equation 3. Equation 2, then the equation 3 was after substituting c, we got it was 8a plus 2b is equals to 9. Okay, so we are going to be solving these equations to get the value of a and b. Okay, so after getting the value of a and b, we will substitute into our equation we created. We used to find this equation, which says that n squared plus bn plus c. Okay, so now our duty, let's go on. Okay, So now our duty is just to simplify this. Okay, so the way we are going to use, we're going to take equation 1. Okay, from equation 1, okay, we're going to make b subject to formula, which becomes b is equals to 4 minus 3a. Okay, so now we are going to be substituting in equation 2. Okay, so substituting in equation 2, we get 8a plus, instead of b, we're substituting 4 minus 3a. Okay, so it's say 4 minus 3a is equals to 9. Okay, solving this, we'll get 8a plus 8 minus 6a, which is equals to 9. Okay, so now we just have to simplify this. We get 8a minus 6a, which is 2a. Then here we get 8 and 9 here. So if 8 goes this side, it becomes 1. Okay, so this means that our a is equals to half. Okay, so now after we get our a, we have to substitute our a into equation for b. Okay, so this is the equation for b. We're substituting our a. So it becomes b is equals to 4 minus 3. Okay, our a is half. Okay, so if you subtract this, you get 5 over 2. Okay, so this will be our answer. Then after that, we just have to substitute c. Okay, c is 3. Okay, 3 minus a minus b. Okay, so we're getting 3 minus our a is half, our b is 5 over 2. Okay, so the next step here, if you subtract this, you get 0. Okay, so after getting 0, now we have to substitute a, b, and c into this equation. Okay, into this equation. This is our equation. Then we will have to compare this equation with that equation given. Okay, so this means that our tn is going to be, let's substitute our a value, which is half n squared, plus our b value is 5 over 2, and then our c value is 0. Okay, so we can leave it like this. Okay, so this will be our answer. Okay, so we can see that this one is the same as that answer. Okay, so we can say that we have successfully shown. Okay, so you can just write it's shown. Okay, so we have successfully shown that the TN is given by this. Now is the continuation of this question. Okay, so the continuation says that what number must be added to t of n minus 1 so that t of n becomes 13,527. Okay, so which is 13,527. The first thing, let's write our equation we get, which is a tn is equals to half n squared plus 5 over 2 n. Okay, so we are going to be using this equation. Let's use this equation to get to, first let's find our value of n, right? So this is the easy way. We're going to be finding the value of n first. Okay, the value of n, how do we find it? We just have to substitute t of n with this number. Okay, so this means that our answer becomes 13,527 is equals to half n squared plus 5 to 5 over 2n. Okay, so now we have a quadratic equation. So now our duty is to solve this quadratic equation, find the value of n, and we go on. Okay, so the first thing is let's put all this one side. It becomes half n squared plus 5 over 2n is equals minus. Okay, so we are putting this side minus 13,527 is equals to 0. Okay, so now our duty is to make sure that we make this one a quadratic equation. Okay, so this becomes, let's multiply each term by 2 so that you get rid of the fractions. Okay, so this it becomes n squared plus 5n, okay, minus 2 multiplied by 13527, okay, which is equals to 0. Okay, so now our duty is to find n. Okay, let's go on. Let's use the quadratic formula. The quadratic formula says that n is equals to minus b plus or minus uh, root b squared minus 4ac over 2a. Okay, this number which is going to come out here is going to be negative. Okay, is going to be positive. So this means that if you say minus and minus, the number is going to be negative. Okay, so we can get rid of this negative sign. Okay, so our n can be found by only saying minus b plus root b squared minus 4ac. Okay, you can try to find the other value of n, but if you found it, it will be negative. So there is no value of n which is negative in this contest. Okay, so this contest, let's substitute the values. We have our minus 5 plus root b squared is 25 minus 4, a is 1, then c is 2, times 3 to 13527. Okay, so we're going to be putting this, then we put 2a. Okay, our a, okay, we forgot our a here. Okay, so 2 here, 2a times 1. Okay, so it becomes like this. Okay, so if you punch this on calculator, you get a answer which is 162. Okay, so this means that which is 162. Okay, so this means that our answer, our value of n is 162. Okay, so after finding the value of n, okay, now we have to find our value of n minus 1. N minus 1, or this means that n minus 1 is equals to 161. Okay, so now we just have to find that how much is t of n minus 1. Okay, using this we can easily find the difference between the numbers. Our equation Tn is equals to half n squared plus 5/2 n. Okay, so now, and we have found that our n value is 162. Okay, so now our duty is to find out what is t of n minus 1. Okay, n minus 1, which is 161. Okay, so we're going to be substituting 161 instead of n. Okay, so this means that T161 is equals to half 161 squared plus 5/2 161. Okay, so if we solve this, we will get 13363. Okay, so this is the t of 161. Okay, then we have our t of 162. Okay, which was our t of n, which was given as a 13527. Okay, so our duty is just to find the difference. Okay, so let's go. Our difference is equals to, we just have to subtract these numbers. Okay, so I'm sure we get 164. Okay, so this will be our difference. Okay, so our question says that which number must be added. Okay, this is the number. Okay, so we should add 164. Let's go to our next question. Our next question is the arithmetic sequence. It says that given an arithmetic sequence with t1 is equals to 8, t2 is equals to 11. Okay, it is asked us to calculate the value of n if t of n is equals to 41. Okay, so this is an arithmetic sequence. Okay, in arithmetic, any term is given by a plus n minus 1 multiplied by d. Okay, so this a will be our first term, and d will be our common difference. Okay, so our n is the nth term. If we want to find the first term, we just put 1. The second term we put 2. Okay, so now we found out that our t1 is equals to 8, which is equals to our a, right? Then our t2 is equals to 11. Okay, so we can use this to find our d. Okay, so our d is found by t1 minus t2. Okay, so which will give us 11 minus 8, which is 3. Okay, so our value of a is 8, our value of d is 3. Okay, so let's substitute here to find the t of n. Okay, we are given a t of n here. Okay, so we are given t of n, we can substitute it as 41 is equals to, our value of a is 8, then plus our difference is 3. Okay, so let's say 3n minus 1. Okay, so now our duty is to find n. As easy as that. Okay, so now we can just solve this equation simply, which is equals to 41 is equals to 8 plus 3n minus 3. Okay, multiplied by 3. Okay, now we have to subtract. Becomes 41 is equals to 5 plus 3n. Okay, now we have to put this side. It becomes 3n is equals to 36. Okay, so this means that our n is equals to 12. Okay, so this is our value of n. And now let's have our next question, which is a continuation from class. It is saying that a new arithmetic sequence P is formed using the term position and term value of the given arithmetic sequence. Okay, so we have a given arithmetic sequence which says that T1 is equals to 8 and T2 is equals to 11. Okay, and we've successfully found out that T12 is equals to 41. Okay, so now let's go on to our next question. For the new sequence, P8 is equals to 1 and P11 is equals to 2. Okay, so we are just taking this and swapping with this one like this. Okay, so this means that our P our P41 is equals to 12. Okay, so the question says that write down the P of 41. Okay, so we can easily write it like this one. Okay, so let's create a formula for this. Okay, this formula is going to be Tn is equals to 8 plus 3 n minus 1. Okay, since we have our A and our D. Okay, then this one is going to be combining these two is going to make sure that P of T of n is equals to n. Okay, so we can simply say that. Okay, so if you want to find this term and this term, we can just use this equation or this equation. Now we are going on with our question. Okay, so our question, the B part says that calculate the value of the first term of the new arithmetic sequence. Okay, we have our sequence we have created on the last chapter. It was saying P8 is equals to 1 and P11 is equals to 2, and we have found that P41 is equals to 12. Okay, so now it is saying that calculate the value of the first term of the new arithmetic sequence. Okay, so now, and we have created the equation that will say that P of T of n is equals to n, right? This was our creation on the last thing, and we will say that T of n is equals to 8 plus 3 n minus 1. Okay, so now we're being asked to find the first term of the new arithmetic sequence. Okay, this is our new arithmetic sequence. Okay, so this means that we are supposed to find p of 1. Okay, which is going to be equals to a certain number. Okay, so we're supposed to find p of 1. Okay, so since we know that this one is the t of n, we can put it here on this equation and find this one. Okay, so we can easily say 1 is equals to 8 plus 3 n minus 1. Okay, so if we solve this equation, we found the value of n, and we can simply substitute p of 1, which is the same thing. Okay, let's substitute here. You can see that 1 is equals to 8 plus 3n minus 3. Okay, this means that 3n is equals to, we put 3n this side, and we put here, it becomes 4. Then 8 minus 4 becomes minus 4. Okay, this is easy. Okay, so we're just solving this equation. Okay, if we simplify this equation, it goes to this. Just try to simplify on your own. Okay, so if we say over 3 over 3, so now n becomes minus 4 over 3. Okay, so if we found n minus 3, okay, so this means that p of 1 is equals to minus 4 3. Okay, p of 1 is our first term. Okay, so we can simply say first term is equals to minus 4 over 3. Okay, easily. Okay, the other way you can solve this one, okay, let me give you the other way you can solve this one, is to create two equations. Since we are told that it's an arithmetic sequence, okay, so we can use this one. Okay, we know our arithmetic sequence. It says that p of n is equals to a plus d n minus 1. Okay, this is the equation of a arithmetic sequence. Okay, but here we have p of 8, okay, which we can say that is a plus d. Our n is 8, so this means that it becomes 7 is equals to, we found our p of 8, which is 1. Okay, then we have p of 11, which is 2. Okay, so we can say that our a plus d, okay, this is 11, so we say minus 1 becomes 10 is equals to 2. Okay, so now we have these two equations. Okay, we have these two equations. Okay, so if we solve these equations, we can find a, which is our first term. Okay, please try this equation, try this method and compare our answer. Okay, it should be the same. Now let's go to our question 4. Our question 4 says that given that g of x is equals to 1 over x minus 1 plus 2. Okay, so now our duty is to write down the equation of the asymptotes of g. Okay, so we can say that our graph g, it was derived from a graph, a hyperbola, which is the f of x is equals to 1 over x. Okay, so this is the correct graph where this one was derived from. Okay, so now we just have to see which transformations were done on this graph to become this graph. Okay, so the first way we have is our x was substituted with x minus 1. Okay, so the meaning of that is that our graph was changed, which means that it was moved 1 unit to the right. Then we have our second change here. We can see that this 2 was added on our equation. Okay, so this means that our graph was moved 2 units upwards. Okay, now with our two transformations, we have to check what happens to the asymptote. Okay, we can see that this graph it looks like this. Okay, let's assume this is our y-axis, and this one is our x-axis. Okay, so now we just have to check what happened to the asymptote. Okay, so now we can see our asymptote. First asymptote is x is equals to 0. Our second asymptote is y is equals to 0. Okay, when this graph was moved 2 units to the right, the x graph changed. Okay, so this becomes x is equals to 1. Okay, the asymptote was moved 1 unit to the right. Okay, so x becomes 1. Okay, it was moved to this side. Okay, then we can see that when this graph was moved 2 units upwards, this y was changed. Okay, it becomes y is equals to 2. Okay, so this means that we have our two asymptote for the new graph, which is x minus 1 and y is equals to 2. Okay, so now you can see that the equations of the asymptotes of g becomes x is equals to 1 and y is equals to 2. Our second part of the question states that draw the graph of g indicating any intercepts with the axis and asymptotes. Okay, so now let's write our equation. G of x is equals to 1 over x minus 1 plus 2. Okay, so my best way of drawing the graph is taking the graph where it was originated, which is a graph f of x is equals to 1 over x. Okay. So we are going to take this graph and we are going to be using it. Okay, so the first thing is we are going to take this graph of fa and draw it here. Okay, you can draw a better one. I'll just draw a rough sketch using my bare hands. Okay, so this is the graph of f of x. Okay, this is the y and this is the x. Okay, so now we are going to do the transformations now. Okay, so we are just going, the shape doesn't change, we're just going to move the asymptotes. Okay, so this x minus 1 means that the asymptote was moved one step to the right. Okay, so this means that our asymptote was moved to become one step to the right. Okay, then this plus 2 means that our asymptote was moved. Okay, so here we have 1, and this means that our asymptote was moved 2 steps upwards. Okay, this means that it became here. Okay, 2. Okay, so this means that we just have to draw our graph here and here of the asymptote. Okay, so now let's draw our graph here. Okay, so let's draw our final graph will be like this. This is our y and this is our x. Okay, this is our y and this is our x. Okay, so now we just have to draw the asymptote lines first. Let's draw in a different color. Okay, so the asymptote line, first asymptote line is here, it is at 1, and the second asymptote line is in here, it is at 2. Okay, so here at 1, here at 2. This is our asymptote line. Okay, now let's draw our graph. If the shape doesn't change, the only the asymptote does change. Okay, so this is the graph here. Okay, let me extend our asymptote. Okay, and this part becomes like this. Okay, now our duty is to find these intercepts. Okay, so asymptote, we know that it is crossing at 1 here, it is crossing at 2 here. Okay, so now just have to check this equation. Okay, so to check this, we have to use this equation. Okay, so we see that this graph is y is g of x is equals to 1 over x minus 1 plus 2. Okay, so now to find the value of y here, we just have to equate x is equals to 0. Okay, so if we put 0 here, okay, so this is the line y is equals to 0. Okay, so we want to find out what is the value of this graph when on the y-axis we put x is equals to 0. Okay, so we just have to say 1 over 0 plus minus 1 plus 2. Okay, so this answer gives us 1. Okay, so this means that we have 1 here. Okay, and next we just have to put g of x is equals to 0 to find out what is the intercept. Okay, so let's put g of x is equals to 0. So if we put 0 is equals to 1 minus x minus 1 plus 2. Okay, so this one it becomes x is equals to half. Okay, you can check the answer, but this is the, if you work out this equation, you get x is equals to half. Okay, so that means that here is half. Okay, so now let's draw our equation on a bigger scale. So our graph becomes like this. Let's draw this one is the y-axis, and this one is the x-axis. So let's say y, let's say x. Okay, so our asymptotes, let me mark our asymptote. This becomes 1, and 2. Okay, and our graph goes like this. And like this. Okay, so now we can see this is 1, this is half, and this is 1. Okay, so this will be our graph. Okay, so we're going to be using this graph to solve. Okay, so now you can see, you can simply, okay, you can write this one, which is equals to x is equals to 1, and this line is equals to y is equals to 2. Okay, so now we can say this graph is y is equals to 1 over x minus 1 plus 2, and this one is the same, y is equals to 1 over x minus 1 plus 2. So we're going to be using this graph in the next question. For our next question, we're going to be using this graph to solve it. Okay, so it says that determine the value of x where the g of x, our graph, is greater than 0. Okay, so we are going to be solving this way. Okay, so the easy way is just we know asymptote, we know everywhere. Okay, so we just have to check where our graph is greater than 0. Okay, so this is 0, right? Okay, so we just have to find the values of x where our graph is greater than 0. Okay, so if we check here, we have our graph which is greater than 0. So you can see here this graph is greater than 0 here, from here going this side, and from here our asymptote going this side. Okay, our asymptote here, okay, going this side. Okay, so when there's a line of asymptote, we just use that line as where the graph is going to end here. Okay, so this means that our graph is going to be when x is less than half, and when x is greater than 1. Okay, so this one becomes our answer. Okay, so it's just a look. If you have drawn the graph, you just have to look. Okay, now we have our last part of question 4. It states that determine the equation of axis of symmetry of g which has the negative gradient. Okay, so let's write our graph. G of x is equals to 1 over x minus 1 plus 2. Okay, so we can see that this our graph was derived from a graph f of x is equals to 1 over x. Okay, this one we talked about it. Okay, so now let's start from this one. Do we know the lines of symmetry of this graph? Okay, so the line of symmetry of this graph, if you don't know, it's y is equals to x and y is equals to minus x. Okay, these are the lines of symmetry. Okay, so now we just have to check what changes have made from this graph to this graph and how these changes affected this line. Okay, as easy as that. Okay, so now we are going to be transforming these lines to new lines as we transform this graph to this graph. Okay, so here we can see the first thing is this one was x minus 1. This means that the graph was moved 1 unit to the right. Okay, so let's go and substitute where there was x here, where there was x with x minus 1. Okay, let's go to our asymptote lines. So this means that y is equals to where there was x, we are putting x minus 1. It becomes x minus 1. Then here y is equals to minus x minus 1. Okay, so everywhere where there was x, we are substituting x minus 1. Okay, let's go on. The next thing we are going to substitute, we are going to add 2 to the whole equation. Okay, so you're going to be adding 2 to the whole equation. Okay, so this one becomes y is equals to x minus 1 plus 2. Then this one becomes y is equals to minus x minus 1 plus 2. Okay, so this we have finished our transformations. Okay, you can see that where there was x, we substituted with the x minus 1, and we added 2 to the whole graph here. Okay, so let's simplify these equations. Okay, so these equations becomes here, if we simplify, we get y is equals to x plus 1, right? Then the bottom part is y is equals to, if we say minus x, then this one becomes 1, then it becomes plus 3. Okay, so now we just have to look for the line which is the, the, the negative gradient. Okay, so here we can see that we just have to check from our equation y is equals to mx plus c. If we check m is negative, this means that that's the negative gradient. Okay, so this means that our asymptote line which has negative gradient is this one. Okay, so our answer becomes y is equals to minus x plus 3. Okay, so this was our our revision for today.